Imagine flying across the cold waters of the North Atlantic Ocean. From high above the clouds, the ocean appears endless. Gray waves stretch across the horizon. Cold winds sweep across the water. Ships move slowly through the vast sea. Nothing seems unusual. Nothing seems mysterious. Yet deep beneath the surface, something extraordinary is happening. Hidden thousands of meters below the waves, a massive waterfall is flowing through the ocean. Not above the sea, not on land, but inside the ocean itself. A giant river of cold water plunges downward into the deep. It flows silently through the darkness. It stretches for hundreds of kilometers, and it is the largest waterfall on Earth. This incredible underwater phenomenon is called the Denmark Strait Cataract. It lies between Greenland and Iceland, and despite its enormous size, almost nobody has ever seen it. Because the entire waterfall exists beneath the surface of the ocean, most people imagine waterfalls on land, water crashing over cliffs, mist rising into the air, thunderous noise echoing through valleys. Places like Niagara Falls or the towering cascade of Angel Falls. These waterfalls are among the most spectacular natural sights on Earth. Millions of people travel across the world to see them. But even the greatest waterfalls on land are tiny, compared to the one hidden beneath the ocean. The Denmark Strait Cataract drops more than 3,500 meters. That is over 11,000 feet. Angel Falls, the tallest waterfall on land, drops less than 1,000 meters, which means the underwater waterfall is more than 3 times taller. But the height is not the most incredible part. The true scale of the waterfall is measured by the volume of water moving through it. Every second, millions of cubic meters of water plunge downward into the depths. This is thousands of times more powerful than Niagara Falls, and yet it happens silently, deep beneath the ocean's surface, invisible to the world above. The Denmark Strait lies between Greenland and Iceland. It connects the Arctic Ocean to the North Atlantic. Cold Arctic water flows south through this narrow passage. This water forms in the freezing polar regions. It becomes extremely cold. It also becomes very salty, and this combination makes it very dense, denser than the surrounding ocean water. When this heavy water reaches the underwater ridge between Greenland and Iceland, gravity begins to pull it downward. The ocean floor suddenly drops. The dense water spills over the ridge. Then it plunges into the deeper layers of the ocean, just like a waterfall. But instead of falling through air, the water falls through other water, creating a hidden cascade beneath the sea. For centuries, sailors crossed these waters without knowing about the underwater waterfall. Ships passed over the Denmark Strait every day. Storms rolled across the ocean. Waves crashed against the hulls of ships. But the waterfall remained invisible. The ocean surface revealed nothing. No massive spray, no roaring sound. No crashing waves. The cascade continued silently below, hidden beneath thousands of meters of water. Scientists first discovered the underwater waterfall. While studying deep ocean currents, researchers were mapping the ocean floor using sonar. They were also tracking the movement of cold water flowing south from the Arctic. Their instruments began detecting something unusual. Huge volumes of water were plunging downward along the sea floor. The currents behaved like a massive river falling off a cliff. At first, the discovery seemed impossible. Water cannot fall through water, or can it? The secret lies in density. Ocean water is not uniform. It changes depending on temperature. It changes depending on salt content. Cold water becomes heavier than warm water. Salty water becomes heavier than fresh water. When different water masses meet in the ocean, the heavier water sinks. And when that sinking water reaches an underwater cliff, it flows downward, just like a waterfall. Except this waterfall is hidden beneath the sea. The Denmark Strait Cataract is not just a natural curiosity. It plays an important role in Earth's climate system. The waterfall helps drive a massive ocean circulation system, known as thermohaline circulation. This system moves water around the entire planet. Warm water travels from the equator toward the poles. Cold water sinks and flows through the deep ocean. This movement helps regulate global temperatures. Without this circulation, Earth's climate would be dramatically different. The underwater waterfall is one of the engines powering this planetary system. Far below the surface, the waterfall continues its silent journey. The cold water plunges down the underwater slope. It spreads across the deep Atlantic Ocean. It moves slowly across the seafloor, invisible to ships above, invisible to satellites in space. Yet it is one of the most powerful forces shaping the global ocean. While the Denmark Strait Cataract is the largest underwater waterfall on Earth, it is not the only place where such strange phenomena occur. Scientists have discovered similar underwater cascades. In several parts of the world, whenever dense water flows across underwater ridges, the same process can occur. Cold water sinks, gravity pulls it downward, and an underwater waterfall forms. However, none of these are as large as the cascade between Greenland and Iceland. The Denmark Strait Cataract remains unmatched. Its scale is difficult to imagine. The waterfall stretches along the ocean floor for hundreds of kilometers. The dense water plunges downward into deeper layers of the Atlantic Ocean. Then it spreads slowly across the sea floor, moving like a silent river beneath the sea. Deep beneath the Denmark Strait, the underwater landscape is dramatic. The ocean floor here forms a steep ridge between Greenland and Iceland. When cold Arctic water reaches this ridge, it spills over the edge. The dense water begins sliding downward along the slope. The current accelerates. It plunges into deeper ocean layers. This underwater cascade creates powerful currents that spread throughout the Atlantic Ocean. These currents influence ocean temperatures. They influence marine ecosystems, and they influence global climate patterns. Scientists continue studying the Denmark Strait Cataract to better understand Earth's oceans. To observe the waterfall, researchers use specialized equipment. Deep ocean sensors measure water temperature. Other instruments measure salinity levels. Some devices track the speed of ocean currents. These tools help scientists map the hidden movement of water beneath the sea. Because the waterfall itself cannot easily be seen, it exists thousands of meters below the ocean surface, at depths where sunlight cannot reach, at depths where pressure is enormous. The environment is dark, cold, and almost completely unexplored. Submarines and remote-operated vehicles have explored parts of the deep ocean. Near the Denmark Strait, these missions reveal a strange underwater world. The seafloor is carved by powerful currents. Sediments are pushed across the ocean floor. Deep valleys and ridges shape the path of the moving water. The underwater waterfall flows along these geological structures, guided by gravity and density differences in the ocean. Even today, much of the deep ocean remains unexplored. Scientists estimate that more than 80% of the ocean floor has never been fully mapped. New discoveries continue to surprise researchers. Hidden mountains, deep trenches, underwater volcanoes, and massive ocean currents that shape the planet in ways we are only beginning to understand. The Denmark Strait Cataract is one of these discoveries, a natural wonder hidden beneath the sea. The underwater waterfall also plays an important role in the global climate system. The sinking cold water helps drive thermohaline circulation. This global ocean system distributes heat around the planet. Warm water flows north from the tropics. Cold water sinks in polar regions. The movement of these currents helps stabilize Earth's climate. Without this circulation system, weather patterns around the world would change dramatically. Some regions might become far colder, others far hotter. Ocean ecosystems could be disrupted. The Denmark Strait waterfall is one of the mechanisms that helps keep this system moving. Imagine the scale of this hidden cascade. A river wider than many cities, falling more than 3 kilometers downward, flowing every second of every day, year after year, century after century, all of it hidden beneath thousands of meters of ocean water, invisible to the world above. From the surface, the Denmark Strait looks completely ordinary. Waves roll across the ocean. Ships travel through the strait. Storms pass overhead. Nothing reveals the enormous waterfall below. Yet deep beneath the waves, millions of tons of water are constantly falling. A silent cascade moving through the darkness of the deep ocean. This hidden waterfall reminds us how mysterious our planet still is. Even in the modern age, Earth continues to surprise us. We have explored mountains, mapped continents, sent spacecraft beyond our planet. Yet much of our own ocean remains unknown. The greatest waterfalls on Earth may not be the ones we see on land. They may be the ones hidden beneath the sea. The Denmark Strait Cataract continues to flow today, a giant river falling silently through the ocean, invisible to ships above, invisible to satellites in space, but constantly shaping the movement of Earth's oceans and reminding us that some of the greatest wonders of our planet remain hidden in the depths below.